have another 1D kinematics problem, example problem, and this one's a tough one, so I'm going to start writing first. A car is rolling backwards downhill on an icy day because I live in the north and we have icy days. The car starts from rest, it accelerates at a painfully insistent rate of half a meter per second squared. Gary, of course it's Gary, sees what's going on and he jumps into the car after it's rolled 10 meters. He starts the car, steps on the brake, it doesn't do anything. After 3 seconds of trying, he puts the car in gear, steps on the gas. The wheels spin, but it's icy, so it takes a moment. He does manage a forward acceleration of 1 meter per second squared. I want to know a couple of things. How fast is the car moving when Gary gets in? How far in total has the car moved when Gary first steps on the gas? How far back does the car move in total from the time it first starts rolling till it comes to a stop? And then how long does it take Gary to get the car back to where it started from the moment it first started rolling? Alright, we'll try this thing with a drawing. I've got a hill and a car. It's starting from rest, and then it's going to start accelerating down the hill. It doesn't want to. Right, here's the front of the car. It doesn't want to go backwards downhill, but it's accelerating. And it's going to do that for 10 meters by the time Gary gets around to doing anything about it. So let's see what we can grab. It starts from rest. V initially equals 0. We can pick anywhere we want to be our x equals 0, and I like that initial position. We know the acceleration is going to be half a meter per second squared. I'm going to throw this as a negative half meter per second squared because I would like to say that uphill will be my positive direction. Don't have to do that. We can make downhill the positive direction, but this is what I've got. This thing is going to roll for 10 meters. So it'll be at x equals negative 10 meters. And then Gary's going to get in. We want to know how fast the car is moving. So we would like to know V final when Gary gets in. That's just the first part of the problem. So I'm going to start with my table and grab what values I can out of this. My x initial, I said that's going to be 0. My x final, that's negative 10 meters. V initial, 0. V final, I don't know, but I'd like to. My acceleration, that's negative half a meter per second squared. And the time, I don't know, but I don't need to. That's not what's being asked. And now I'm going to write my kinematic equations. And I may as well write what's not in these. This really is my starting point every time. I am looking for V final. If I'm looking for V final, I don't want to use equation 1. That's not going to work for me. So I can use equations 2 or 3. I don't have information about time, so if I can use equation 3, I don't need to have information about time, and that would be great. I'm going to do that. V final squared is V initial squared plus 2a delta x. V initial is 0. That's going to make that even easier. To a delta x, I'm looking for V final, not V final squared, so I'm going to take the square root of both sides. And then I can plug in. And I get that my V final is going to be 2 times negative 0.5, that's negative 1, times negative 10 is positive 10, and then I'm going to take the square root of that. So the square root of positive 10 is 3.16 meters per second. Anytime I take a square root, I can get a positive or a negative result. I'm moving to the left, I'm moving in my negative direction, so I'm going to get a negative 3.16 meters per second. And that answers question 1. Question 2. How far in total has the car moved when Gary first steps on the gas? So when Gary first steps on the gas, we need to see what else has happened. Gary sees what's going on, he jumps in after it's rolled 10 meters, we've already taken care of that. He starts the car and steps on the brake, but nothing happens after 3 seconds of this. So 3 more seconds go by. We can find how long this process takes, and we may as well because we're going to end up needing it for question 4. So if I wanted to find time, now I'm going to use probably equation 2 because that's the simpler one. I'm going to say V final equals V initial plus A T. I'm solving for T. This guy is 0. I get my negative 3.16 meters per second divided by my negative half a meter per second squared. And I get 7.32 seconds for my time. So I'll put that in too. So the next question was, how far in total has the car moved when Gary first steps on the gas? I can take this problem and start it from the point that I'm on now. So I can say, I know the speed, I know the velocity, I know the time, and I can do that. I can also just start the problem back at the beginning, and I think that's the direction that I'm going to go with this. So I will make a new table. I'm going to still call my x initial 0. I'm going to say my x final, I don't know this one now, because that's what I'm trying to find, right? How far in total has the car moved? So I would like x final. I don't know this value, but I'd like to. My initial velocity is 0 because I started back at the top at that beginning point. My final velocity, I don't actually know what this is. I've got negative 3.16 meters after it's gone 10 meters, but now I'm going to have gone farther, so it's going to have continued to speed up. My acceleration, I'm going to keep that guy at negative 0.5 meters per second squared. And now I need 3 seconds after Gary got in the car. He got in the car at 7.32 seconds. So 7.32 seconds plus 3 seconds means this car has been rolling for 10.32 seconds. I'm looking for x final, and here are my equations again. I'm looking for x final, and I don't have v final. Equation 1 looks like a great bet for this. So let's do that. Equation 1. X final equals x initial v initial t half a t squared. My x initial is 0, my v initial is 0, so just half a t squared, and I can plug in because I know those values. Here's my a, here's my t. And when I do that, I get x final equals 26.63 meters negative. And I'm going to fill in my table. So this is when Gary steps on the gas, where the other table was when Gary gets into the car. So question 1, done. Question 2, done. Question 3, how far back does the car move in total? I want to be pretty careful with this because for this first part, when Gary gets in the car, I've got that acceleration of negative 0.5 meters per second squared. For the second part, Gary is in the car and now he's going to step on the gas, but he hasn't yet. I'm still at negative 0.5 meters per second squared. So if I were to kind of graph this acceleration, because everyone likes a good graph, right? Time acceleration I have right here. This is 7.32 seconds. So this is Gary getting into the car. I have this acceleration of negative half a meter per second squared. Here at 10.32 seconds, this is step on gas. I continue to have that same acceleration. Then I'm going to step on the gas, and after a while, I don't know the time, but the car is going to come to a stop. For that stretch, instead of having a negative 0.5 meters per second squared, I have a positive 1 meter per second squared. So I can break my time. I've done this first segment, I did this second segment, now I'm working on this third segment. I want to find when the car comes to a stop, but to do that, I need to make sure that I recognize that there is a change in acceleration here. So what I'm going to need is at the end of this second segment right here, I need to find what my speed is going to be, what my velocity is going to be, because then I'm bringing in a new acceleration. So I do need to find right here that final velocity. I can do that using equation 2, because I know everything else. V final equals V initial plus A t, that's 0, so just acceleration times time, and I'm going to get negative 5.16 meters per second, and I can put that in here. I found down here that I was moving 3.16 meters per second to the left. Now I'm moving 5.16 meters per second to the left. So I am speeding up, and that makes sense. Now I've got a whole new problem to do. So what I have now, if I want to go back to this graph, if I want to go back to my picture, I've got this car. That was unkind. I've got this car like this. I'm on a hill. And this car is already moving. It's moving at negative 5.16 meters per second. And now I am applying an acceleration this way of 1 meter per second squared, if I go all the way back to the problem. You step on the gas, and now you manage a net forward acceleration of 1 meter per second squared. We want to find how far does the car move in total. So we are looking again for an x final. And the in total part tells us we're going to have some things to do. At the end of this second segment of time right here, we are at a position of negative 26.63 meters. That's when we get there. So if we are going to do this problem, we need to pick a spot that we call our x equals 0. I don't mind calling this an x equals 0 because it's going to make my equations easier again. But if I do, I have to remember that in the end I'm going to have to add this negative 26.63 meters that I have already moved. I started out up here. So from there to where I am now is 26.63 meters. If I call this new spot x initial equals 0, I just have to make sure that in the end I'm measuring from here. Not a big deal. I'm going to grab my same three equations from before, because I used those enough. And I'm going to drop those equations right here. Then I'm going to make my table again. And I'm going to fill in what values I can. My x initial is 0. My x final, I don't know, but that's the one I'm looking for. My v initial is negative 5.16 meters per second. I'm going to skip v final for a second. My acceleration is 1 meter per second squared. And I don't know how long this takes, but that's not the variable that I'm solving for. If I go back to the question, how far back in total does the car move? The car will keep moving back until it comes to a stop. So what I'm looking for is how far the car has moved when v final is 0. V final is 0. I'm looking for x final. I don't know the time. I would like to use equation 3. Equation 3 doesn't require me to know time, and that's pretty nice. So here we go. V final squared is v initial squared plus 2a delta x. And this is with my foot on the gas. Well, with Gary's foot on the gas. I'm solving for delta x. My v final is going to be 0. I'm just looking at my table. That's the other nice part about these tables, is I am not mixing up one part of the problem with the other anymore. So I'm solving for delta x. I get delta x will be negative v initial squared over 2a, and I can plug in my values. Negative, and I get a delta x of 13.31 meters. That is how far I'm sliding from the time that I put my foot on the gas. If I go back here, that means my car is going to come to a stop. Gary's car. I guess we don't know it's Gary's car. He might just be trying to help someone out. It stops here. What we know is that this distance, that's what we just found, is 13.31 meters. I was asked to find the distance from the total distance, so I need this distance, which is my 13.31 meters that I just found, plus the 26.63 meters that I had already slid, is 39.94 meters total. Back to the question. So that one's done. Last one, told you this was a long, difficult problem. How long does it take Gary to get the car back to where it started from the moment he gets in? Alright. He gets in after it has slid for 7.32 seconds. He starts stepping on the gas when we have slid for 10.32 seconds. Then we said, so that took care of this block of time. Then we said, new problem. We're going to go here. So we reset the clock, reset the time, and reset the position, I mean. And now, we had the car stopping there, and it's going to take some time to get back to where we started. During that time, my acceleration is still 1 meter per second squared. So now I'm doing this problem. This was questions 1 and 2. This is question 3. Now I'm doing question 4. I'm going to make a table again. So this is with foot on the gas up until the moment that I come to back to my initial position. So foot on gas until we're back to the start. It's a long title for a table, but so it is. So what I can do with this, instead of, so maybe I labeled these a little bit differently. What I had here, I had question 1 was really just that part. Question 2, I took the whole thing because I went back to the beginning. Question 3 was that. And now question 4, I'm going to actually go right back there because my acceleration was the same all the way through. I didn't find this time, so I don't really want to split that up more than I have to. X initial. My X initial, I can call 0 wherever I want. I'm going to stick with here. My X final, I need to get back to my starting point. So my X final is going to be 26.63 meters. My V initial, I had still. My V final, I don't know. I'm sliding backwards, slowing down, coming to a stop, speeding up, and getting back to here. So I don't know what speed I'm going when I get here. V final is going to be 0. I do know my acceleration is 1 meter per second squared. And my time, well, I don't know that either. I'm looking for, how long does it take? I'm looking for time. What's more, I'm looking for the time. I'm looking for the time from the moment he gets in. So I would like this amount of time right here, from here to here. That's the time that I need. I'm going to figure out with my table, I'm going to figure out this amount of time. Right, because I'm starting on 0, ending at 26.63. This is the amount of time that I'm stepping on the gas. So when I find that time to get my final answer, I'm going to have to add in these 3 seconds. Here we go. I've got my table. I don't need my picture anymore. And I'm going to go with these same equations again. I will even take this table and move it into a fresh space. So there we go. Looking for time. I don't know V final, but I know all these other quantities. Maybe now I could use equation 1. 1 doesn't require me to know V final. However, here's the thing. If I use equation 1, I'm going to have a V initial t, I'm going to have a half a t squared, and I'm going to have a linear term, or a constant term. When I do this, I will end up with something where I have to solve a quadratic equation. It's not a big problem, it's not anything like that. So let me write that out real quick so that you can see what I'm talking about. I will have, this term will be 0, but that's all. I'm going to have something with a t squared, a t, and a non-t, so I'm going to have to solve a quadratic equation. Not a big deal, but another option would be, this would be really easy to solve for time if I knew the final speed, right? If I knew the final velocity, I would use equation 2 to solve for time. I don't know the final velocity, but I could use equation 3 to find the final velocity. So let me try that. So I'm going to say this uses quadratic equation to find t. Other option, I'm going to use equation 3 to find V final. Once I have that, then I can use equation 2. So equation 3 says V final squared is V initial squared plus 2a delta x. And I can just plug in right away. V final will be the square root of this. Which is 8.94 meters per second. Before, when I took a square root, I made sure to say I can have positive and negative square roots. This one, it makes sense that my final velocity is going to be a positive number because I'm moving back up that hill. So this thing is 8.94 meters per second. Now that I've got that, now I can use equation 2. Equation 2 says V final is V initial plus acceleration times time. I'm looking for time, but aren't we all? V final minus V initial over A. And the time that I get here is 14.1 seconds. If I go back to my drawing and my graph, there we go. I said I'm looking for the total time. The time from my table works out to be 14.1 seconds. I've got 3 seconds to add to that, so my t total is going to be 14.1 seconds plus my 3 seconds. So I'm going to get 17.1 seconds. Going all the way back. That answers my last question. And I am finished.